Algebra 2 Honors 6.2. We're looking at the natural base e, and it's linked to exponential growth and decay. And e is a number that we see occurring in nature for different things of application, and it just talks about right here, the history of mathematics is marked by the discovery of numbers such as pi and I. Another special number is denoted by the letter E. You have to remember, E is a numerical value. E's to just one decimal place, approximately 2.7. And an interesting thing that we use, you'll see this in calculus, if you take 1 plus 1 divided by x raised to the x, and you let x get larger and larger and larger, that expression approaches the value of e. So they show if you let x be 10, so that means you're taking 1 plus 1 over 10 raised to the 10th. You get this value. If you instead let it be 100, 1 plus 1 over 100 to the 100th, then you get this value, 10 squared. And notice now that's 2.7. And as it's 10 to the 6th, we're getting closer. Notice that these are agreeing to 4 decimal places. And so as you increase the value of x, this approaches the value of e. And so the natural base of e is irrational, and it's defined as x approaches positive infinity, this approaches e. So e is 2.71828 to 5 decimal places. That's an approximation. So we're going to use the property of properties of exponents to do some simplifying, much like was on your last test. And here, so e is a number, just like if it was 5 to the 2nd times 5 to the 9th, we would say the bases are the same, so when you multiply, you add exponents and you get 5 to the 11th. E is a numerical value. It's just not a nice, neat, clean integer. So this is going to be e to the 2 plus 9, and you're going to get e to the 11th. And that's your answer. So we're going to want these to be exact. Leave your answer in terms of e. And so on this next one, you can take 25 divided by 5 is 5, and then we have like bases, and so you subtract the exponents. And you get 5e to the first, which we will just write 5e. And then this next one, when you have things taken to the nth power, you take each thing to the nth power when things inside are all being multiplied. And everything in here is being multiplied. So you're going to get a 2 to the 5th, e to the negative 3x to the 5th. And 2 to the 5th is 32. And powers of powers we multiply, so we end up multiplying these, getting e to the negative 15x. But you are going to need to write with final answer with positive exponents. So we are going to say that this is 32. The 32 stays in the numerator. The 32 is to a positive 1. It doesn't have a negative exponent. And drop the e to the bottom, and we have e to the 15x. So be careful on that. Make sure that it's clear, that you don't write it where I can't tell that the 15x is an exponent. All right, so then we have exponential growth and decay. And you're going to need to show a table of values, just kind of like what you did on the last assignment with graphing. And here we have y equals 2.5 e to the x. Well, in this case, I can think of it, if we're thinking about ab to the x, it's related to that. Our a value is 2.5. And our b value is approximately 2.7, right? And so b is greater than 1. So this is going to be exponential growth. It's going to be exponential growth. And so we are going to go ahead and I'm going to let you use Desmos or a scientific calculator to evaluate on these. And I'm going to leave a little space just in case we need a little more clarification on these. I have -2, -1, 0, 1, and 2. I might need some values, -3, -4, or +3, +4 to get a nice clean growth happening. And so again, we're going to go to Desmos. All right, and I'm going to go to the graphing calculator. And in this one, I'm going to go ahead and attempt to get rid of that old one we were just doing notes on. All right, so add table. And I can fill in the X values right here, I think. Yeah, there we go. I'm going to move this over for a second. And I lost my table. All right, so I am going to just enter Desmos again. Graphing calculator. There's my table. I wasn't sure how to get it back up. All right, so there. So on this table, I'm going to have I'm going to add the table, and then I'm going to go ahead and put in a -2, followed by a -1, followed by 0, followed by 1, followed by 2. And I'm going to come up in the second column, and I'm going to delete all that, and I'm going to put in 2.5, and then I need E. So I'm going to hit functions and miscellaneous. It isn't there. Okay, so let's try ABC. I don't think it'll use E that way, but I'm going to go ahead and try it. E, oh, yep, I think we've got it going. So it knows that if you press E to use it as its stored value. And then 2.5 E to the X. So hit the A to the B button. And remember, I need X and then hit 1 after it, so it does that subtitle. And so these are the correct values for that expression. You can see what's being graphed is starting to look like an exponential growth. And so now I'm going to go back and get my notability. And I'm going to put these values in. So I can't really graph much better than to the nearest tenth, so I'm going to just put those in to the nearest tenth. And put that off to the side for a moment. And graph those. So at -2, I'm at 0.3. At -1, I'm at 0.9. Now, the y-intercept in this case is not 1 because the a value was 2.5. The value of a is going to be your y-intercept. And then at 1, we are at 6.8. And that looks good to me. I know it's just going to continue to have it run parallel to the x-axis. So it doesn't look like it's going to cross through. And there we have those plotted. So then what is the y-intercept? And in this case, it's not 0 anymore. It's 2.5. It's that value of a. And what is my horizontal asymptote? It is still y equals 0. It's the x-axis. And my domain on this is all reals. And my range is 0 to infinity. All right, then let's look at this next one. Now, in this one, the base isn't just E because this has an effect on it. And basically, since this is negative, this is going to be exponential decay. The algebra on that is I can write this as e to the -0.2 to the x. And if I approximate that, e to the negative 0.2, and I'm not going to decimals to do it, I'm just doing it on my calculator. E to the negative 0.2 is about 0.819 approximately. And so if I get it where this is just the variable, this is the base and it's less than 1, and so that's how it works out to be exponential decay. But that's going to happen when that coefficient of x is negative. In the first one, the coefficient of x was positive, so it's going to be exponential growth because you have 2.7 to the first. But if it's negative, it's going to end up being decay. All right, so with that, I'm going to do a table of values. And for that, I'm going to come over to the calculator, and I'm going to change this up, and I'm going to make it, we'll go to E, and then we'll go back to a to the b is negative 0.2, and then I have to have x sub 1. Now, if I look at that on the graph, that barely has that decay happening. And so what I did is I saw, that's not getting me a good curve. So I said, let's do negative 4, let's do negative 6. That's starting to be a little bit better. I could even do negative 8. And then let's go to the right some more. Let's do positive 4, positive 6, positive 8. And that's working out a little bit better for me. And so I am going to come over here and fill something out, and notice that I have my graphs going by 2. So I don't have to put every one of these down, but I kind of like that negative 8, maybe negative 6, negative 4, I don't know, negative 2, 0, 2, 4, 6, 8. And so we've got negative 8 is negative is 4.95. And negative 6 is 3.32. 3.3 is probably good. And negative 4 is 2.2 is good enough. And negative 2 was 1.5. 0 was 1. Notice that the A value for this was 1. There wasn't a number in front of E other than 1. And at 2, we're at 0.7. And at 4, we're at 0.4. And at 6, we're at 0.3. And at 8, we're at 0.2. So that's maybe a few more than I need, but I do like that. Okay, we're going negative 2, 4, 6, negative 8. We're almost up at 5. So this only goes up to 4, so we're up here. Negative 6, we're at 3.3. And negative 4, we're at 2.2. Negative 2, we're at 1.5. 0, we're at 1. And at 2, we're at 0.7. Whoops, that's the wrong spot because every 2 boxes is 1 unit. At 4, we're at 0.4. And at 6, we're at 0.3, and then 0.2. So there we go. And then it's leveling off and running parallel to x-axis, or to the x-axis. So the y-intercept, in this case, is 1 because the a value was 1. Horizontal asymptote is y equals 0. Domain, negative infinity to infinity, and the range is 0 to infinity. And there you have your graph. So I want to see tables of values on your homework. All right, then we have we had interest that was compounded quarterly in the last set of notes, and in your homework you had to do it monthly and daily. One of your problems will have you compare compounded continuously, and when you compound continuously, instead of having 1 plus r over n, that 1 plus r over n, as n gets bigger, we found out becomes e. It's related back to this definition right here. That's at 1 plus 1, some rate over n. And as that n raised to the n gets larger and larger, that value approaches e. So the more times I compound it, basically that has that effect of that value going to infinity and that value going to e. So here we have a is equal to p e to the rt, where r is your rate and t is your time. And so you have a problem very, very similar to this in your homework. And so you've got two things happening. You've got a graph of your friend's account, but for your account, you have an equation. Which account has the greater principal? And by the way, you can see that this is your PE to the RT, your principal, 3,900. E is your base for compounding continuously, and you raise that to your rate. So 0.05 means it's a 5% annual rate, and then T is your time in years. So that's that PE to the RT. And so it says, which account has the greater principal? Well, this is very much related to y is equal to AB to the x, where that coefficient in front of the base is your y-intercept. And so if I look at my y-intercept being 4,000, your friend's equation is going to be a is equal to 4,000 e to the, we don't know what the rate is. They didn't give that to us. But I know that the starting amount for the friend is 4,000. That is their principal. And yours is a is equal to 3,900 e to the 0.05t. And so the friend's account had the greater principal. And you need to mention the amount, so I know specifically that you knew what it was, versus you had 3,900. All right, and then it says, which account has a greater balance after 14 years? Well, for the friends, you're going to use the graph because you don't know R, and so we're going to use the graph. And so that's a matter of understanding that the input is years and the output is your balance. And they want to know after 14 years. So you need to go, okay, here's 14 years, and you read up, find that point, and you read this way, and you have to figure out what is that value approximately. And so I would say it's approximately 9,200. So after 14 years, your friend has approximately 9,200. You have, after 14 years, y is equal to, you have to calculate it, 4,000 e to the, oops, I was looking at the wrong one, 3,900 e to the 0.05 times 14. So we're going to go over and calculate that. And I'm going to go here, scientific. And so we have 3,900. And then again, I'm going to go to, and this one, when you're in the scientific calculator, they do give you an e to the x. So e to the, back to the main, 0.05, and then times 14. And so you have, and I mean, you can only estimate about to 9,200 on your friends, so to the nearest dollar is fine. If you put 64 cents, that's fine. I don't mind. And so your friend, so you have to identify what your friend had, what you have, and then answer the question. So your friend has a greater balance after 14 years. All right, so just note that in one of your problems, you're going to have to look for, your principal being, say, 400, and your rate, say it's 8%, and watch for compounded continuously. Anytime it says that, that means you're going to be using A equals PE to the RT. And then you look for, how many years. So what's in the account after 3 years, and you would be plugging in, change your percent to a decimal, and then evaluate that. So you have to do that, I think, in one of your problems. So 400, and then in this one, if I hit function, there is an e to the, and then I can go back to main, 0.08 times, oops. Maybe if I use the parentheses, yeah. It didn't let me do the times symbol without dropping it down. There we go. So you've got, so you might have some of that in your homework. That's it.